Next, we'll talk about functions as graphs. The graph of a function is the picture that represents all of the solutions or ordered pairs for the equation or the function. So to determine if a graph is a function, we will use the vertical line test, which states that if a vertical line intersects the graph at more than one point, then the graph is not a function. So my question is, are these relations also functions? To determine that, what we're going to do is put your pencil on your paper and vertically to make it a vertical line, and what I want you to do is to drag it across your picture. Now at any one point, your pencil is only touching one part of the blue graph at a time. Is that correct? As you pass it through, at no point is it touching more than one point at a time. Now some students might argue that these arrows might keep pointing up forever, but they are also still going out forever. So even though it may look like they're going vertically, they are still going out, and so they will never actually touch more than one at a point. So because my vertical line is only touching one point on the blue at a time as you pass your pencil through it, then we can say that yes, this relation is a function. Now what this vertical line does is it's monitoring all the x values. For any one x value, it's only supposed to have one y value. So on the x-axis, when your pencil comes vertically, it's saying at that x value, you can only have one y value, and you only do. When you move it over, at this x value, you only have one y value down here. And what you're doing is you're checking every single x value, making sure it only has one y value, and so that no x values are double dating or trying to date more than one y. So you're basically using the definition of a function to test graphs. Now drag your pencil over. Uh-oh. This is a problem here. Look at this. Your x, this one x, is trying to date this y up here in the blue and this y down here. That's not okay. So I'm just going to go ahead and draw a line here. This x is trying to date that y and that y at the same time. This is not a function. Not. Okay? Alright, grab your pencil again. We pass through the third one. It touches once, touches once, touches once, touches once, touches once. At any one point, we're only touching one blue value. So if I drew a line, this x value is only touching one y value at any one point. And when you pass your pencil through it, again, every single value on the x direction is only dating one y value at a time. So this is yes, it is a function. Okay, so we are going to use our domain and range using interval notation, which we talked about in our last lesson. In order to find the domain, or the set of all x values of the graph, we need to look at the endpoints of the relation graphed from left to right. When you're talking about all of the domains, we're talking how far left can you go, how far right can you go. Now, in order to find the range, or all of the y values of the graph, we need to look at the endpoints of the relation graphed from bottom to top. Domains are left to right because we're talking about x values. Ranges is from bottom to top because we're talking about y values. So on the next example, I want you to answer the following questions. Is the relation a function? Yes or no? Then tell me what the domain is, and then tell me what the range is. So the function, you need to grab your pencil and drag it through. Well, right there we have a problem. That x value is trying to date a y value up on the top side of town and a y value on the bottom side of town, the south side. And that is not okay. This is not a function. So is the relation a function? No. Now, even though it's not a function, it does have a domain and a range. When we're talking about domain, we're talking about the endpoints from left to right. So how far left can this graph go? Well, the farthest left it can go is -6. And then the farthest right this graph can go looks like +5 to me. So the lowest it can go is -6, comma, the highest it can go is 5 in the x direction. Sometimes using your pencil and dragging it across might help. The first x value is at -5, yes values, yes values, yes values, yes values, until +5. I'm sorry, the first value was at -6 till +5. So sometimes that pencil can help you again. Can I use my endpoints? Sure I can, so I use brackets. So to find the range, you're talking how low you can go, comma, how high you can go, but because we're going in the y direction, we're talking about bottom to top. So the lowest it can go here in the y direction looks like -5, and the highest it can go in the y direction looks like 1, 2, 3. Again, I'm allowed to include my endpoints, so I can use brackets. Now, if you want to rotate your pencil, you can drag your pencil from the bottom of the screen to the top of the screen to see where the first value hits and the last value hits. Okay, so for this next one, I'm going to grab my pencil and then I'm going to say, how is this a function, yes or no? So as I drag my pencil through, it looks like at every single point, my pencil is only touching one blue value at any one point. So is this a function? Yes, it is a function. Now my domain is all of the values, all of the x values. So as I'm going left to right, what is my first x value? Well, it looks like my first x value starts at 1 and it ends at 7. I'm allowed to include my endpoints, so I keep my values. Sometimes using a pencil might help. As you can see, oh, okay, there's my first value as I'm going left to right. My first value starts at 1, yes values, yes values, yes values, yes values, up until 7. And so then I have no more values. My pencil only touches blue from 1 to 7. That might help. So to get the range, we're talking how low you can go, comma, how high you can go. But because we're talking about the y direction, we're going bottom from top. So the lowest value I can see is at 0. The highest value in the y direction is 3. So it goes from 0 to 3. If you want to rotate your pencil, you can do that and say, how low can you go? Well, the first time my pencil touches the blue is at 0. And then the last time the pencil touches the blue is at 3. So all the values from 0 to 3 are all of the values I can have in my range. So I'm going to include both the endpoints because there's no open circles here, so that's why I include them. So I think we have answered those questions.